This is Unit 1, Lesson 6. I will update these notes so they say Unit 1, Lesson 6. We're going to be talking about absolute values and their transformations. The first thing that we need to know about is absolute values parent function. As a reminder, to do a linear function, you can put this in your notes if you need to. Linear, we should already know. F of x, the same thing as y, and it's going to equal x. That is a linear function. That is the parent function. Okay. We graph it using y equals mx plus b. But if we're talking about the linear parent, that's f of x equals x. Otherwise known as a mother function, that we look similar to our mothers, but we are not exactly the same. So the parent function or the mother function of absolute value will have the absolute value bars with x inside of it. Okay. So then we need to talk about what is absolute value. And absolute value is the distance from 0 on a number line. You can write the word or put the symbol on a number line. Okay, what does that mean? It means I'm starting right here at 0 and I want to move 3 spaces. Well, I can go to the right 1, 2, 3 and get there. But if I want to move 3 spaces, I can also go to the left. Now, I understand that that is a negative number, but when I'm talking about distance, I moved right 3 or I move left 3. It's like when you're driving a car. You drive forward 5 miles, and you can drive in reverse 5 miles. That does not take miles off of your car, so it's still a distance of 5 miles, whether I drove it forward or backward, it doesn't matter, except it's dangerous to drive in reverse. So you will never have a negative distance. Okay? Distance, because that's what absolute value is, cannot be negative. Okay? So again, if I want to move, if I tell you you're on a number line and you need to move five spaces, you can go to the right 5, or you can go to the left 5 and you'll be correct because you've moved 5 spaces. So I'm going to teach you how to type this in your calculator. You should probably write these directions down right in here. So when you turn your graphing calculator on, you're going to go to y equals. So write that and then push that button if you're practicing. Let me take out what's in there. I'm trying to get the glare to get off the calculator. I don't really know how to do that. Okay, so once you're in y equals, you're going to hit the math button. So you can write that down, math. And then when you push the math button, there's nothing helpful there. But if you go to the right under number, so you can just put a right arrow and UM for number. You see the first thing is abs, so you want to hit enter. When you hit enter, the absolute value bars show up in y equals. That's why we need to be in y equals and go there first so that we can graph it. So you put x inside, and this is our parent function. We're going to graph it to see what it looks like. Absolute value makes a v. Why does it do that? We're going to find out in just a second. But first we're going to go to our table. We're going to fill these values in. So we want to look at negative 8. And you notice at negative 8 that y is 8. Okay. Why? Because the distance from 0 to negative 8 back here on the number line would be 8 spaces, no negative. Okay. So then you should be able to assume if you're going to go 4 spaces and move to negative 4, you've moved 4 spaces on the number line, so it's a positive 4. Now, if you want to move to 0, you don't move anywhere, so it's 0 movement. If you start at 0, because that's where we start, we didn't move. All right, and then if I want to go to the right 4, I'm still moving 4 spaces away. If I want to go to the right 8, I'm still moving 8 spaces away. Okay, so we're going to plot these points and make this picture. So negative 8, positive 8, negative 4, positive 4, 0, 0. And I'm just plotting all these points, 4, 4, and 8, 8. This will continue on forever. Okay. And then we need to come up with the domain and range, because that's not new to us. We've been doing domain and range for a long time. Well, since school started anyways. So we'll go with interval notation because it's the last one on that foldable and you like it the most. So remember, I'm looking from the left to the right. And as I look to the left, my function's headed up, but it's also headed left. I'm moving over here more and more and more. So if I look all the way out here at negative 20 and look up, I find my function. So I'm coming from negative infinity. I don't have a left starting point. There's an arrow there. Okay, so the same is true on the right side. I don't have a right stopping point because I have an arrow. So I'm headed to infinity. Now my range, remember, is from the bottom. Here's my bottom, that's the lowest. It's 0. And it heads to the top, which are arrows, so I'm headed to infinity. Okay. This is your transformations equation. This is your parent function right here. This is how we move your parent function around. Okay, this is mommy, your mother function. These are going to be the kid functions, okay, how we move them around. So we're going to start here with the parent function that we have in the calculator, and we're going to compare this one. So in my calculator, I'm going to go back to y equals, and I'm going to leave my parent function in because I'm going to compare. So I'm going to go math again to number and enter. I need to put x inside because it's inside, and then I need to right arrow. I need to be outside the absolute value to put plus 5. We're going to see what happens. That's our parent in blue, and red is my new function. And I can see that it moved up 5 on the y-axis. So you're going to put that right here just like this. We moved up 5. Okay? That is the transformation. Where did the function move? This one moved up 5. So we're going to go back and look at this one. So I'm going to come down here and I'm just going to arrow over to the plus and hit a minus instead. And then I'm going to hit a 3 instead of that 5. And I'm going to graph it. And there's my mother function again, my parent. Here's my new function. Notice that this one moved down 3. Okay. So maybe you know what's going to happen with positive 1. Or at least an educated guess. So we put a plus 1 after, and we graph. Again, mother function comes first. And there's my new function. And we did move up 1. So hopefully you can tell when we go back here and change this to minus 7. You're probably going to guess that it goes down 7. Let's see if it does. And there's your mother function. This is our new function, and sure enough, we've moved down 7. Okay. So when we are talking about D, how do I know that this is D? Notice that these numbers are behind the absolute value at the end, and there's my D at the end. So you can color code that if you want, or highlight the same color, however you want to do that. Okay, but up and down is how it moved my function, so we're going to say it's a vertical shift. You can write y-axis if you want. It's going to move it up and down on that y-axis. Okay. Now, the next one that we're going to do is notice that we're looking at the number inside the absolute value. And when I look up here, that's going to be C. So now we're talking about C. And we're going to see how it affects my function in here. So back in my calculator, y equals, I'm going to leave my parent function in the first, and I'm going to go change this one. So this one asks me to have minus 2 inside with x, and then when I go outside, I'm going to hit delete, delete. Okay, notice that I match now. And when I hit graph, there's my mother function, my parent, in blue always. Oh, my new function. It moved to the right 2. That's weird, but we'll go ahead and put that right 2. And wants to not work. Okay, so we're going to go down here. We're going to change this to plus 6. You just type right over it. It's inside, so we hit graph. And positive 6, oh, moved us to the left. 6. now the next one, x minus 1, just to be sure. Minus moved me to the right last time. Let's see if it does again. So let's see if we move to the right one. Sure looks like, yep. We move to the right one. Okay. And then minus 4, I'm sorry, plus 4. So when we add 4, last time adding moved us to the left. Let's see if it does again. So there's my parent function. And yep, sure did. Move me to the left 4. Okay, so what can we say about this C value? Left and right is a horizontal shift. Sorry, my pen is running out. Horizontal. Okay, so it's our horizontal shift. I always have students make a note for themselves that a positive is actually going to move you to the left and a negative will move you to the right. This is the opposite of what you assume will happen. Okay, this is the opposite of what you assume. Okay, now we have one letter left. It's A, it's in front, and it is next to the absolute value, which means times. So I can see this 2 here is multiplying by the absolute value. So we're going to go ahead and put this in. So go back to y equals. I'm leaving my parent in again. I'm going to put a 2 in front. Oh, I got rid of my absolute value. Sorry. So we're going to go 2, and then math, right arrow over to number. There we go. And we're going to put our x in. Okay, so now I match this one, and we're going to describe what we see happen. Again, my parent function, my mother function will be blue. And my new function, you notice that it got skinnier. It's just not as fat as the parent. So we call that a vertical stretch. What do I mean by that? I mean that we take the y-axis, because that's our vertical axis, and we stretch it. We pull it apart. So if you think about pulling a rubber band from top to bottom, as you pull it apart, it comes in, it gets skinnier. So what we did was we stretched the y-axis to pull those blue lines in to the red. Okay, so let's check 2/3. So I'm going to make this alpha, alpha y equals, and you can type a fraction in. So I want 2 divided by 3, and I'm going to delete that. So 2/3 needs to be out front, and we're going to graph it. Again, there's your parent, and here's your new one. Do you see that that one is fatter? It fell out. So instead of taking the y-axis and stretching it to make it skinnier, we took the y-axis and we pushed it together. We just squished it. And that's called a vertical compression. We compressed the y-axis. We pushed it together, and as you push it from, I don't want the light to, okay, trying to get the light, there we go. As you take the y-axis and you smash it together and you push, that parent function in blue is going to fall out. It's going to get fatter. Okay, so we're going to go look at 5. So let's delete. We're going to put a 5 there. Okay, and again, your parent function stays blue. So if I'm looking correctly, it looks like it would be a stretch. Yes, you can see that that blue function got much skinnier by grabbing the y-axis on each end and pulling up and down, stretching it, we got skinnier. Okay, so the natural assumption would be that fraction 1/4 should compress. Let's check it out and see if it does. So I'm going to do second insert. I'm going to do 1/4. I'm going to get rid of the 5. So if we're right, this function should get fatter. It should fall closer to the x-axis. Oh, and I definitely see that happening. So this is a vertical compression. Okay, that's our vertical compression. All right, now A is going to cause a vertical stretch or a compression. And we have to determine when that's going to happen. Notice that our stretches were at 2 and 5, and our compressions were at 2/3 and 1/4. So I would say we would compress when my A is less than 1. And I would say that we stretch when A is greater than 1. 2 and 5 are bigger than 1. 2/3, 1/4 are less than 1. They're not a whole. Okay? So then we're going to look at what happens if I make that number in front negative. So that is a picture we want to look at. So I'm going to go to y equals. I swear I checked my calculator right before this video, and of course now it wants to die. Awesome. Okay, so we're going to delete that. We're going to put a negative. Don't put a minus sign. Make sure you use the negative down here below 3. Okay, so we've got negative with the absolute value. So let's look at it. When you look at the blue one, there's our parent function. When you look at the red one, it is the same width. I did not stretch it or compress it at all. I didn't move it up or down. I didn't move it left or right. All that happened is it flipped over. And in math, we call that a reflection. So it causes, sorry, let me put that, a reflection. That negative A in the front causes a reflection, and we go over the x-axis. You see that it flipped down right over the x-axis. Okay, so I want to show you something. Up here, 2 stretched. It got skinnier. Let's look at what happens when we have a negative 2. So I'm going to go in here. I'm going to type a 2. Oh, man. Math. Absolute value x. Okay, hopefully this calculator will make it. So when we hit graph, there's your mother function. And now we're doing negative 2. Do you see that it did reflect? It reflected. But it also got skinnier. So this is what's important. You actually have 2 transformations. This negative is your reflect. The 2 is your vertical. You can put V, stretch. Okay, very important. They did 2 separate things. I reflected, that was the negative. Stretching, I got skinnier, that is the 2. Okay, so when I go in here and do negative 2/3, okay, so I should technically, by what I'm seeing, still see a reflection for my negative, and 2/3 was a vertical compression. Let's see if we see that, meaning fatter. It's going to get fatter. So there's my parent. I do see that it reflected, and it's definitely wider than the parent. So again, this is the reflect piece. This is still a vertical compression. Okay, so it's 2 pieces that do something different. Negative reflect, the number still does my compression like it did before. So negative 1/4, we should still see a reflection, and we should see it get wider as well, a compression, smash the y-axis, and it is much wider. So again, we're going to say reflect, and then we're going to say vertical compression. They're separate pieces. We write them separate. All right, why do we need this? You're going to be graphing absolute value before too long, and you need to know your transformations. So I'm going to use this sheet to practice these problems. Okay, so, sorry, I'm trying to get this. There we go. All right, so according to this first problem, I would identify what letters you have first. So when you look at this equation, is that A, C, or D for -4? It's inside, so it's got to be C. So I just teach my students to write a C. Plus 6 is outside of, and when you look at this equation, D is outside of, so we make that D. And then we're going to state our transformations. So here, I'm going to look at, let's see if I can bring it up here, there we go. We're going to look at C. Now notice that -2 went to the right, and we have -4. -1 went to the right. So we're going to say that we go right 4. We also wrote a note that a negative moves to the right, so we're going right 4. Okay. Plus 6 is D. Here's where I wrote about D. and positives, positive, they both moved up. So I'm going to say we're going to go up 6. Okay. Those are your transformations. This function was moved to the right 4 and up 6. If I show you in the calculator, you're going to see that. Come on. We're going to do math, enter abs. We want x minus 4 plus 6. Okay, so we're looking to see, compared to the parent, did we move right 4 and up 6? So let's see. There's my new function. Look at the vertex. It was at 0, 0. 1, 2, 3, 4. And if you count up, you're going to get up 6. Just hard to count here. But right 4, and it moved up 6. It grabbed the vertex right here at 0, 0, and it drug it to the right 4, up 6. There's my new baby function. Mother function, baby function. We look similar, but we are not the same. Okay? Now, if you look at this one, we have a negative 2 in front. That's going to be my A. If you look in your notes, we did a negative 2 right here. So we're going to say negative is going to reflect. Negative causes my function to reflect, flip over the x-axis. Okay. My 2 is going to cause a vertical stretch. It's going to get skinnier. Because, again, 2 is greater than 1, not negative 2, just 2. We're looking only at the 2. Okay, and the negative does the reflecting. And then we need positive 5. Oh, I forgot to label. That's A. This is C. Again, A is in front, C is inside. Okay, so I'm looking in the C section at positives. Here's C. Positives say they go to the left. And notice positive went to the left, positive went to the left. So we're going to say left 5. Those are my transformations for that problem. Okay, and this is how you do these. So let's look at the next two. We're going to label these, and this 3 in the front is A. And then inside, sorry, I'm up here, is C. So I know where to look in my notes. So I'm looking at the A section, here it is. I'm going to have a vertical stretch when I'm greater than 1. 3 is greater than 1, so we're going to say vertical stretch. I forgot to tell you what you have to put by 3 so that you know how much you're stretching by. Okay. And then plus 1 is C, so we're in this section right here. And we have a positive. Positive should move to the left. So we're going to go left 1. Those are your transformations for that one. And this one right here. Okay, again, we're out front, so that's A. We're at the back. Oh, that's different. C is inside, D is outside. So we've got D. So A is 1/2, so I need to look down here. Here's my A. 1/2 is not greater than 1. It's less than 1 because it's 0.5. So we're going to say a vertical compression. You may shorten both of those. V, compression, which you have to put by 1/2, telling me how much you're compressing by. Okay. D is this section here, and I've got a minus, and if you look, minuses moved down. So we're going to say down 3. Okay. These transformations are going to help you a lot as soon as we start graphing. All right, now look at this function right here. It's in front, that negative is, so it's going to be A. Plus 8 is at the very back, so that's D. So I'm going to look down here for negative A. Here it is. Causes a reflection. So I'm going to say reflect. Okay? Reflect. Plus 8. That's D. So I'm up here. And positive moved up. Positive moved up. So I'm going to go up 8. All right. And the last one, we need to be careful here. At the very beginning, we've got A. Inside we have C. And outside we have D. So we've got all 3 this time, and every one of them is going to cause a transformation. So when I look at A, it is negative. So I need to say I have a reflection. So the negative only is the reflect. You're going to flip that V. Instead of opening up, it's now going to open down, which I can't do very well, sorry. 6/5. I don't include the negative did the reflecting, so 6/5. Lots of students say, oh, it's a fraction, so I'm less than 1. But 6 divided by 5 is not less than 1. It's greater than 1. So this is a vertical stretch. And then we're going to move for D. We're looking here. We're going to move vertically, and it's positive. So positive moved up, positive moved up. So we're going to say that we're going to go up 1. And that is how we work on transformations that we will be using to graph functions.